Hello students, welcome to Theory of Machines course. Different machines that we see in our day-to-day life uses different mechanisms to perform their tasks. They rely on one or more actuators like hydraulic cylinder or electrical motor for their actuation. One of the important parameters considered while selecting the actuators for a mechanism is degrees of freedom of a mechanism. In this video, we are going to see what a degrees of freedom of a mechanism means. Before that, let us see how few mechanisms that we are going to see in this video are actuated. At first, the front loader of a famous earth mover, the JCB. The front loader is equipped with two cylinders to control the entire movement of the mechanism. These two cylinders are actuated by means of a control lever inside the operator cabin. Operating this dual control lever vertically, the first cylinder is actuated and the bucket moves up and down. And the horizontal movement of the lever actuates the second cylinder, which controls the front bucket angle. Let us look at it. Now, let us look into the backhoe of JCB. The backhoe is fitted with 4 cylinders. Let us see how the backhoe moves when we actuate each cylinder. Finally, consider an even more simpler mechanism, the truck-mounted crane. This crane has just one cylinder to vary the angle of the main link called boom. Let us see what happens when we actuate it. As we have seen, different mechanisms need different number of actuators. Suppose, given a mechanism, how could we decide the number of actuators required to control it? The answer lies in finding degrees of freedom of the particular mechanism. But at first, what is degrees of freedom of a mechanism? Answering the question is our objective today. Let's find out. More specifically, in this video, we are going to understand what is degrees of freedom of a mechanism. Then, we are going to derive the general relationship for finding degrees of freedom of a mechanism. And finally, we are going to apply the resulting relation to find out the degrees of freedom of different mechanisms. Let's do it. The degrees of freedom is defined as the minimum number of independent input parameters required to completely control the motion of entire mechanism. Once again, let us consider the truck-mounted crane. This is the line diagram of the mechanism. Varying the length of the red link, the angle of the boom is controlled. So, the entire mechanism is actuated by varying just one parameter of the mechanism, which is the length of the red link. So, by definition, the degrees of freedom of truck mounted crane is 1. Similarly, the degrees of freedom of the front loader of the JCB is 2, and for the back loader it is 4. Now we have found the degrees of freedom by counting the number of actuators in a mechanism. But actually it is the other way round. First, the number of degrees of freedom of a mechanism is calculated, and using that the number of actuators required is found. Now, how could one find out the degrees of freedom of a mechanism without knowing the number of actuators involved? Let us see. I want you to remember few characteristics of a mechanism. These three conditions helps us to find the degrees of freedom of a mechanism. Let us look at them one by one. The first one is, a mechanism is a system of rigid bodies or connection of rigid bodies called links. So, let us find out the degrees of freedom of a single link or single object. Let's consider a Cartesian XYZ coordinate system and a free object in this coordinate system. So, what are all the different independent motions it can make? It can translate along x-axis, y-axis and z-axis, or it can rotate about all these three axes. In total, an object which is free to move in a space can have 6 independent motions. Or we could say in other words that if an object is completely free to move in a space, the robot needs 6 positional information of this object to correctly grab it. So, the degrees of freedom of an object in space is 6. But in our studies, the most of the links are not free to move in space. Rather, they are restricted to a single plane. These objects are called planar objects. If a mechanism is made of planar links which are restricted to move parallel to a single plane, then the mechanism is called planar mechanism. We are going to deal with just planar mechanisms. Because of the planar restriction, this object cannot move along z-axis and it cannot rotate about x and y-axis. An example for such planar objects is a human being walking on a plane. When he walks, He could walk in forward direction or in sideways, or they can rotate about vertical axis to change the direction. And another example of such planar objects is the duster while rubbing the whiteboard. Since these planar objects has only three independent motions, the degrees of freedom of such objects is 3. The second characteristics of a mechanism we are interested in is the connection between the different links of a mechanism. Let us see how the connection between links affects the degrees of freedom of the mechanism. The prismatic joint and revolute joint are the two widely used joints. Suppose one of the links connected by this joint is fixed, then the degrees of freedom of the other link will be reduced to just 1. Let us see why it is so. If the white links of the two joints are fixed, then in the revolute joint, the other link could just make the rotation about an axis as shown in the animation. Whereas the link connected by prismatic joint translates along an axis. So, in both the cases, the degrees of freedom permitted by these joints is just 1. That is why these joints are called 1 degrees of freedom joints. These joints actually restricts 2 degrees of freedom of the link. Now, let us focus on the third condition of mechanism. The degrees of freedom of a fixed link is always 0. This is because it does not move in any direction at any time at any cost. If we have n number of unconnected system of links, then the total degrees of freedom becomes n times 3. With all these conclusions, we are now equipped to find the degrees of freedom of a mechanism. Let's derive the relationship for the degrees of freedom of a mechanism. Once again, let me have all the 3 characteristics we are interested in. By the first condition, an n-link planar mechanism can have the degrees of freedom of not more than 3 times n. But since one of the link of the mechanism is fixed, the maximum degrees of freedom reduces to 3 times n minus 1. And if there are j1 number of 1 degrees of freedom joints, each of the joints restricts 2 degrees of freedom. And similarly, each 1 degrees of freedom joints reduces 1 degrees of freedom of the mechanism. So if we subtract them, we will get the relationship for degrees of freedom. This condition is called Kurzberg criteria for finding degrees of freedom. But our analysis in this course is restricted to mechanisms having just 1 degrees of freedom joints. We will not going to consider the mechanisms with 2 degrees of freedom joints. So the value of J2 will become 0. Updating this in the Kurzbach criterion, we will get a simplified criterion for finding the degrees of freedom of mechanisms having just 1 degrees of freedom. This simplified criteria is called Grapler's criteria for finding the degrees of freedom of planar mechanisms. Now we are ready with a criterion for finding degrees of freedom of different planar mechanisms. As a first example, let's find mobility of a 4-bar mechanism. A 4-bar mechanisms have 4 links, namely a frame, which is fixed one, and a crank, which makes 360-degree revolution, and a rocker, which is an output link. Finally, the connecting link. So the number of links is 4, and these links are connected by 4 revolute joints. So the J1 value is also 4. Substituting these values in Grapler criterion, we will get the degrees of freedom of 4-bar mechanisms as 1. So to control the 4-bar mechanism, we need just only one actuator. Now let's consider a slider crank mechanism. The slider crank mechanism also has 4 links, and it has 3 revolute joints and 1 prismatic joints. All these joints are 1 degrees of freedom joints. So the n value and J1 value is equal to 4. So just like 4-bar mechanisms, the degrees of freedom of slider crank mechanism also 4. Note that the mechanism used in truck mounted crane is just an inversion of slider crank mechanism. So in this video, at first we have defined the degrees of freedom of a mechanism. Then we have derived a general condition for finding degrees of freedom of planar mechanisms. This is called Kurzbach criterion. Then we have simplified the Kurzbach criterion to find out the degrees of freedom of mechanisms with just 1 degrees of freedom joints. This simplified criterion is called Grapler criterion. Thank you.